By the late 20th century, the scientific study of altered states had stalled. Research into psychedelic compounds was largely abandoned, categorized by major institutions as a recreational hazard rather than a field of medical inquiry. At the same time, mainstream psychiatry was reaching a dead end. Schizophrenia was being treated almost exclusively as a dopamine disorder, and treatments for depression were plateauing as pharmaceutical innovation slowed to a crawl. The most extreme anomalies of human experience, mystical states, hallucinations, and the total loss of the sense of self, remained unmapped. They were treated as subjective ghosts in the machine that hard science couldn't touch. This created a significant blind spot. Without a way to measure these states through biological evidence, the medical community had no way to understand their mechanics, let alone use them as a tool for healing. In Zurich, Dr. Franz X. Vollenweider looked at this vacuum through an unusual lens. He was a biochemist and a medical doctor, but he had also completed a traditional Freudian training analysis. His research began with a simple premise. If a specific molecule, like psilocybin, reliably triggers a shift in consciousness, that subjective experience must correspond to a measurable change in brain activity. To find that connection, he utilized a new generation of neuroimaging tools. By using EEG and PET scans, his team could monitor the metabolism of the living brain as it transitioned into a psychedelic state. Vollenweider wasn't interested in the philosophical debate surrounding these substances. He was interested in building a biological map of how they functioned. In 1998, Vollenweider launched a study to see if he could isolate the exact trigger for altered reality. He administered psilocybin to healthy volunteers to create a temporary, controlled model of psychosis. First, he attempted to block the drug's effects using standard dopamine-blocking antipsychotics. This was the era's primary treatment for hallucinations, yet in this study it failed completely. The breakthrough came when the team introduced a compound called ketanserin. Immediately, subjects reported their hallucinations and feelings of ego dissolution had completely vanished. This result isolated the mechanics of the experience. Ketanserin serves one primary function. It binds specifically to the serotonin 5-HT2A receptor, preventing other molecules from activating it. This proved that the trip wasn't a result of generalized chemical noise. It was the result of a specific molecular interaction, shifting the focus of psychiatric research toward the serotonin system. Having identified the receptor, Vollenweider's team examined how this signal traveled through the brain's wider systems, specifically the loop connecting the cortex and the thalamus. Normally, the thalamus acts as a security filter, limiting the sensory data reaching the cortex. But Vollenweider found when 5-HT2A receptors are activated, this gate fails, allowing a flood of raw, unfiltered information to saturate the brain. This PET scan shows the result, a state called metabolic hyperfrontality. The frontal cortex is working at maximum capacity, burning through glucose as it tries to make sense of the information deluge. This demonstrated that a psychedelic experience is the result of an actual anatomical shift. The subjective feeling of an expanded mind is the result of a security system that has been temporarily bypassed. By establishing these measurable biological mechanics, Vollenweider provided a framework that allowed the scientific community to move past political stigma. His data helped reclassify these compounds as legitimate tools for neuroscience. To maintain this momentum, he founded the Heffter Research Center in Zurich. It was designed to be a permanent, multidisciplinary hub for the study of human consciousness. By 2010, his research reached a major turning point. In a paper for Nature Review's Neuroscience, he argued that if these substances could temporarily alter the brain's circuits, they could potentially be used to repair them in patients with mood disorders. This led to a new objective for the field, investigating whether the broken filter state could be leveraged as a form of clinical intervention. Modern imaging shows the contrast clearly. A brain suffering from severe depression is often rigid, locked into a few repetitive, isolated pathways. Under psilocybin, that same brain becomes a hyper-connected web of firing neurons. The current therapeutic hypothesis is that this state creates a window of neuroplasticity. By temporarily dismantling the brain's rigid filters, the mind is given the flexibility to wire new, healthier connections. Today's clinical trials for depression and addiction are built directly on Vollenweider's biological mapping. His early scans provided the evidence that made these modern treatments possible. Franz Vollenweider proved that the anomalies of human consciousness were not beyond the reach of science. He showed that by understanding exactly how the mind's systems break, we can begin to learn how to reset them.